Welcome to Teacher Ava's class. Our lesson for today is about the sum of finite and infinite geometric sequence. To solve for the sum of finite geometric sequence, we have the formula S sub n equals a sub 1 times the quantity of 1 minus r raised to n all over 1 minus r. Or we can also have another formula. S sub n equals a sub 1 minus a sub 1 r raised to n all over 1 minus r. So you can use any of the two formula. Let's say, for example, we have to find the sum of the first 8 terms of geometric sequence 1, 2, 4, 8, 16, 32, 64, 128. So let us identify the given. We have the a sub 1, or the first term, which is 1. We also have the number of terms 8. Common ratio in this sequence is 2. And then we need to solve for S sub 8, or the sum of the first 8 terms of the geometric sequence. Let us solve this example using the two formula. So let us start with the first formula. S sub n equals a sub 1 times the quantity of 1 minus r raised to n all over 1 minus r. So by substitution, we have 1 times the quantity of 1 minus 2 raised to 8 all over 1 minus 2. Let us simplify 2 raised to 8. That is 2 times 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 2. So we have 1 times the quantity of 1 minus 256 all over negative 1. So we have negative 1 because 1 minus 2, the answer is negative 1. So let us now simplify 1 minus 256. We can now have 1 times the quantity of negative 255 over negative 1. 1 times negative 255, the answer is negative 255 divided by negative 1, the answer is positive 255. So in this example, S sub 8 is equal to 255. So let us use another formula. That is S sub n equals a sub 1 minus a sub 1 r raised to n all over 1 minus r. So let us substitute the given. S sub 8 equals 1 minus 1 times 2 raised to 8 over 1 minus 2. Simplify again 2 raised to 8 and yung 1 minus 2. So we can have 1 minus 256 all over negative 1. So 1 minus 256, that is negative 255 divided by negative 1 is still positive 255. Therefore, the sum of the first 8 terms of the sequence is 255. So you can use any of the two formula. It is up to you. Another example, if we are finding the sum of the first 6 terms of the geometric sequence 4, 12, 36, we have the first term 4, number of terms 6, common ratio here is 3, and then we need to solve for S sub 6. Let us solve this using the two formulas. First one is S sub n equals a sub 1 times the quantity of 1 minus r raised to n all over 1 minus r. Let us substitute the value. We have S sub 6 equals 4 times the quantity of 1 minus 3 raised to 6 all over 1 minus 3. You need to solve first 3 raised to 6. So we have S sub 6 equals 4 times the quantity of 1 minus 729 all over negative 2. So simplify 1 minus 729. We will come up with 4 times negative 728 over negative 2. 4 times negative 728, the answer is negative 2,912. Divided by negative 2, S sub 6 is 1,456. Another formula, S sub n equals A sub 1 minus A sub 1 r raised to n all over 1 minus r. Substitute the value. We have S sub 6 equals 4 minus 4 times 3 raised to 6. So you have to simplify 3 raised to 6 and then multiply it by 4. So we have 4 minus 2,916 all over negative 2. So 4 minus 2,916, the answer is negative 2,912 divided by negative 2, S sub 6 is 1,456. Therefore, the sum of the first 6 terms of the given sequence is 1,456. So you may use any of the two formula. The answer is still the same. Alright, so let us now move on to the sum of finite geometric sequence given the three conditions. So to get the sum of a finite geometric sequence if the common ratio is 1, we will use the formula S sub n equals A sub 1 times n. If the common ratio is negative 1 and the number of terms or n is even, simply use S sub n equals 0. If r or the common ratio is negative 1 and n or number of terms is odd, let us use S sub n equals A sub 1. In this example, 2, 2, 2, 2, 2, 2, 2. The common ratio here is 1 because 2 times 1, the answer is 2 times 1, 2 times 1, 2. And the number of terms is 7 and it is odd number. So if the common ratio is 1, we will use S sub n equals A sub 1 times n. So by substitution, we have S sub 7 equals yung A sub 1 natin which is 2 times 7. And 2 times 7, the answer is 14. Therefore, S sub 7 is 14. Let us have another example. Find the sum of the first 10 terms of 1, negative 1, 1, negative 1, 1. So the common ratio here is negative 1 because 1 times negative 1, the answer is negative 1 times negative 1, 1. So on and so forth. And then number of terms is 10 and it is even. If the common ratio is negative 1 and n is even, we will use S sub n equals 0. And S sub 10 is equal to 0. So, letter C, sum of the first 13 terms of 3, negative 3, 3, negative 3, 3. 13 terms. The common ratio here is negative 1 and number of terms is 13 and it is odd number. So we will use S sub n equals A sub 1. So S sub 13 is equal to 3. I hope you understand the three easiest condition in finding the sum of the terms of a finite geometric sequence. So let us now move on to the sum of the infinite geometric sequence. So to get the sum of the infinite geometric sequence, the first thing to do is to get the value of r, or simply find the common ratio. If the common ratio or r is less than 1 and is greater than negative 1, then it is possible to get the sum. Again, r is less than 1 and is greater than negative 1. What are those numbers? Less than 1 but greater than negative 1. So, example here is 1/2, 1/3, fractions like that, 0.75, 0.8, 81 positive, but it must be less than 1. Another one, if the common ratio is greater than or equal to 1, or the common ratio is less than or equal to -1, then it is impossible to get the sum. So let's say, for example, the common ratio is 1/2. It is possible to get the sum. If it is possible to get the sum, you will use the formula S sub infinity, because we are solving for infinite geometric sequence, equals A sub 1 all over 1 minus R. So let us have this example. If we have 5, 15, 45, 135, is it possible or impossible to get the sum? What is the common ratio? Okay, since the value of our common ratio is 3, then it is impossible to get the sum. Number 2, we have 2, 2, 2, 2, 2, 2, so on and so forth. What is the common ratio here? The common ratio here is 1. And there are infinite terms. Therefore, it is impossible to get the sum. If we have 3/4, 3/8, 3/16, 3 over 32, so on and so forth, is it possible to get the sum? Yes, since the value of R, or the common ratio here, is 1/2, then it is possible to get the sum. Because 3/4 times 1/2, the answer is 3 over 8. 3 over 8 times 1/2, the answer is 3 over 16. So R is 1/2 and possible to get the sum. So let us solve for the sum of this infinite geometric sequence. Okay, so let us identify the given. We have A sub 1 3/4, and then common ratio is 1/2. So let us use the formula S sub infinity equals A sub 1 over 1 minus R. So by substitution, we have 3/4 over 1 minus 1/2. We need to solve first the denominator 1 minus 1/2. And 1 minus 1/2, the answer is 1/2. So we have 3/4 over 1/2. So we need to divide the two fractions, 3/4 divided by 1/2, or simply I will teach you a technique, multiply outside by the outside, inside by the inside. So 3 times 2, the answer is 6. 1 times 4, the answer is 4. So simply we have 6 over 4. We need to simplify our answer. So we have sum of the infinity is equal to 3 over 2. Or if you want to change it into mixed number, that is 1 and 1/2. But in my class, I'm accepting 3 over 2. It's okay na for me. Alright? Let us have another example. If we have 16, 4, 1, 1/4, is it possible to get the sum? Alright. Since the value of R is 1/4, then it is possible to get the sum. Okay, so let us solve this. Our A sub 1 is 16, and then common ratio is 1/4. So by substitution, we have 16 over 1 minus 1/4. We need to solve first 1 minus 1/4. So we have 16 over 3/4. So we will divide fractions again. Always consider that since 16 is a whole number, that is always with the denominator of 1. So we have 16 times 4, the answer is 64, and then 1 times 3, the answer is 3. So S sub infinity is equal to 64 over 3. That's enough, but if you want again to change it into mixed number, that will become 21 and 1/3. It's up to you. Again, I'm accepting 64 over 3. So thank you for watching. See you again on our next class discussion.